Whatever the fingerprint scanner, we call it as a biometric sensor. So that is also an example of UART device. So these are the UART devices. UART device. Okay, so with the help of this transmitter and receiver pin, we can write and we can read data from these devices. Okay. So writing will be done at the same time. That's why it is called as a full duplex. So these both are data pins only. TXD and RXD, both pins are data pins. And this UART, whatever the UART on-chip peripheral of microcontroller, this can transmit and receive the data at the same time. That's why it is called as a full duplex protocol. It is a full duplex UART. So this UART is designed for serial communication. Okay, now you can understand the difference in serial and parallel communication. So here only one data line is used to transmit the data and only one data line is used to receive the data. That's why it is called as a serial communication. So parallel communication is nothing but 8 data lines will be used to transmit the data and receive the data. Okay, but here only one line to transmit the data, one line to receive the data. So on single line you can send only one bit at a time. On single line, on this single data line, you can transmit only one bit at a time and you can receive only one bit at a time. That's why this is called as a serial communication. Parallel communication means 8 data lines will be there to transmit the data and 8 data lines to receive the data. So that is called as a parallel communication. So UART is specially designed for serial communication. This is very old protocol and this protocol is still used in the companies. Many companies are using this UART protocol for communicating with external devices or sometimes for debugging microcontroller board as well as testing the microcontroller boards. And nowadays this UART is used for remote logins also. They are used for remote login also in single board computers. So there is one more embedded board that is called as single board computer. That is called as single board computer. In short, it is called as SBC. So there are now some popular single board computers are Raspberry Pi, BeagleBone Black, we call it as a triple B, we call it as a RPi. So there are some boards that are called as a single board computers. They are called as single board computer. Arduino is not called as single board computer because Arduino doesn't have the OS. So this Raspberry Pi and BeagleBone Black. On Raspberry Pi and BeagleBone Black, we can run OS, Linux OS we can run on this board. Okay, and these boards are computers only. These boards are nothing but computers. And if you want to connect Raspberry Pi or BeagleBone Black to your laptop, so it is possible to connect these boards to your laptop with the help of UART protocol. With the help of UART protocol, we can connect them. Okay, so that is also later on, like suppose if you if offline started and if I take the IoT, then I will explain Raspberry Pi and BeagleBone Black, how to connect and how to do this remote login using UART. So that also we will discuss. Okay, so with these boards, we can do remote login with the help of UART. So it is widely used protocol in embedded industry. Next one, this 8051 has two 16-bit timers or counters. So right now you don't concentrate on what is meaning of 16-bit timer or 16-bit counter. You just say, okay, timers and counters are available. 2 timers and counters are available. So the role of timer or why timer is used in microcontroller. So timers are used for delay generation. In the microcontroller, please note on, I think we didn't discuss this last 3 points. Timer in the microcontroller, timer is used to generate a delay within a program. Timer is used to generate a delay within a program. Make a note of this. Timer is used to generate a delay within a program. Remember, delay function. We are going to write a program for delay, and we will write a program to generate the delay using software method, using timer method, hardware method. And delay function, whatever the delay function we are going to learn and we are going to write. So that delay function is one of the important function in embedded system. And that delay function can be written with the help of timer. So timer has also important like IO pins. Okay, so delay function is used in every embedded project. You cannot write a single embedded project without using a delay. You cannot write any project, any embedded project without using timer or without using a delay. So that's why timer is very, very important in the project. Next, counters. Okay, write down about the counter. Counter is used to count external clock pulses or external events. Counter is used to count external clock pulses or external events. Counter is used to count external clock pulses or external events. Counter is used to count external clock pulses or external events. Okay, in most of the cases, I will tell you one real-time project where this counter is used. One of the real-time project where the counter is used. So you know the visitors counter. You know the visitors counter widely used in shopping malls. Then it is used in airports. So we have the visitors counter project. Like in shopping malls, when you enter into the shopping mall, so you will have one square box and you have to cross from that square box. So that is called as visitors counter. And that visitors counter is widely used in shopping malls and airports, railway stations, bus stands, hospitals nowadays are used in the hospitals also, and in the defense areas also nowadays. They are used in the defense areas also. Yeah, that is actually that visitors counter is used for counting how many people entered into shopping mall and how many people exit from shopping mall. So that's the reason that those visitor counters are used. Okay, so that is one real-time example. Yeah, in metro stations also it is used. In metro stations also, railway stations, airport, shopping mall, some of the hospitals also, defense area. So there it is used. Okay, so that is for this is one of the real-time project where the counters are used. Okay, so when I come to this timers and counter topic, we will discuss how to generate delay and how to count external events or external clock pulses. Okay, next one, total 6 number of interrupts are available. Interrupt sources are available. Total 6 means including reset, 6 interrupts are available. Okay, so interrupt will help you to write or help you to do multitasking in the microcontroller. Without using interrupt, you cannot do multitasking. Without using interrupt, you cannot do multitasking. By using interrupt, you can do multitasking in the microcontroller programming. And you can utilize the CPU time with the help of interrupt. We can utilize the CPU time in a better way. So when I come to interrupt topic, we will discuss more on this interrupts. So total 6 interrupts are available. Out of 6, one is reset interrupt. And what are the remaining interrupts? What are the remaining 5 interrupts? That also we will discuss in detail when I come to the interrupt handling. So okay, in the interrupt, you remember there is something called as a maskable and non-maskable interrupt. So this reset comes under the non-maskable interrupt. Non-maskable interrupt is nothing but an CPU cannot ignore or CPU cannot avoid this non-maskable interrupt. Non-maskable interrupt is nothing but an CPU cannot avoid or cannot ignore this interrupt. Whenever reset interrupt is triggered, CPU must and should serve this interrupt. So this type of interrupt is called as non-maskable interrupt. Okay. Next one is the size of next one. When I come to interrupt topic, we will discuss more in the detail. Size of data bus is 8 bits here and size of address bus is 16 bit here. Okay. See, when you are interfacing external memory to 8051 microcontroller, when you are interfacing external memory to microcontroller, so with the help of data bus and only data bus and address bus is used to interface external memory. If you want to interface external memory, we have to use only data bus or address bus. Okay, bidirectional bus is data bus. Size of data bus is 8 bits and size of address bus is 16 bits. Size of address bus is 16 bit. And the maximum limit, suppose if you are connecting the external memory, maximum limit of the memory depends upon size of address bus. This is address bus and this is data bus. The maximum limit of the memory depends upon size of address bus. So the size of address bus means now here size of address bus is 16 bit. So the maximum limit of the memory becomes 2^16. Maximum limit of the memory becomes 2^16. So suppose if somebody asked you how much maximum memory that we can interface to microcontroller, so your answer should be straightforward. The maximum memory that can be interfaced with the microcontroller depends upon the size of address bus, or the limit of maximum memory which is connected to microcontroller or which is interfaced with microcontroller depends upon size of address bus. Your answer should be very clear. Okay, suppose if the size of address bus is 16 bit, that means you can connect external memory up to 2^16. So 2^16 is nothing but 64 KB. You cannot connect a memory greater than 64 KB. You cannot connect the memory which is greater than 64 KB. So the minimum size or the starting address of the memory always starts from 0. We say it is 0 KB. Okay, the maximum limit given as up to 64 KB. That means you can connect external memory up to you can connect external memory 1 KB, 2 KB, 4 KB, 8 KB, 16 KB, 32 KB, 64 KB, but not more than 64 KB. So this limitation depends upon size of address bus. This limitation depends upon size of address bus. Okay, so make a note of this. So I have given the maximum limit of the external memory that can be interfaced with 8051 is 2^16. Make sure that the size of data bus will not decide how much extra memory we can interface to microcontroller. Only the address bus will decide how much extra memory we can interface to microcontroller. Take note of this. So this is about features of 8051. Okay, what is subroutine? Subroutine means function. In case of assembly language, function is called as subroutine. No, yes, R1, your point is right. Suppose if you connect more than 64 KB to 8051, if you connect more than 64 KB to 8051, so we can use up to 64 KB. It is not like we cannot connect more than 64 KB to microcontroller. Okay, if it is more than 64 KB of memory, if it is more than 64 KB of memory, that means whatever the memory chip you will use it, right? Whatever the memory chip you will use it. So this memory chip will have more than 16 address buses. So out of, suppose if the 20 address buses, suppose whatever the memory you are interfacing is 1 MB, whatever memory you are interfacing is 1 MB. So 1 MB, for 1 MB total 20 address buses will be there, 1 to 20. So out of 20, only 1 to 16 address buses can be connected to micro 8051. Okay, and this remaining 4 will be left open. The remaining 4 will be left open. So you can use only first 64 KB out of 1 MB, like that. Yeah, if the address bus size is 20 bits, then the maximum limit is 2:20. Total memory, no, suppose if you are going for external memory, so then internal memory will not be counted. Internal memory will not be counted. If you connect external memory, suppose if you are connecting external RAM, that is okay. But if you connect external ROM, or if you connect external flash memory, then internal ROM will not be used, or internal flash memory will not be used. Only external flash memory will be used. But suppose if you connect external RAM, then internal RAM will be used and external RAM also will be used. Okay, so this is about features of 8051 we have discussed. So our today's point of discussion is block diagram. Block diagram of 8051. People call it as architecture of 8051. We'll discuss pin diagram and pin description. Pin diagram and pin description. Okay, so we will discuss these points today. Okay, let me show you the block diagram. Okay, block diagram concept is very simple. Block diagram concept is very simple. So most of the time, what we do is we mug up this block diagram. So obviously, like when we are pursuing our BE, when we are pursuing our engineering, that time we used to remember the block diagram. We used to mug up this block diagram and then we try to draw it. But the concept of drawing or logic of drawing the block diagram is very simple. If you remember features of microcontroller, it is very easy to draw the block diagram. If you remember features of microcontroller, it becomes very easy to draw the block diagram. So the logic behind drawing the block diagram is you should know features of microcontroller. You can draw block diagram very easily. Okay. So there is one more point I would like to add in the feature is supporting frequency. Supporting frequency of 8051 is up to 12 megahertz, and working voltage is 5 volt. Supporting frequency is up to 12 megahertz. So 8051 will support frequency up to 12 megahertz, and 8051 microcontroller works on 5 volt. So that related to every microcontroller, working voltage is up to 5 volt. Okay, and the frequency, why we should think about the frequency, or why we should consider this frequency in the features. Frequency will decide speed of microcontroller. Frequency will decide speed of microcontroller. Okay, so how this will be like speed will be decided, that we will discuss in coming topics. So for time being, remember that frequency will decide speed of microcontroller. Less frequency, less speed of microcontroller. More frequency, more speed of microcontroller. If you compare 12 megahertz and if you compare 100 megahertz, suppose 8051 supporting frequency is up to 12 megahertz. You cannot give the frequency which is more than 12 megahertz. Okay. Now you have another microcontroller which will support frequency up to 100 megahertz. So obviously the microcontroller which support 100 megahertz frequency is faster than 8051. So 8051 supporting frequency is 12 megahertz, and the microcontroller which has supporting frequency of 100 megahertz, which is faster than 8051. Okay. So frequency of microcontroller or frequency will decide speed of microcontroller. Okay, now come to this block diagram. So the logic behind drawing the block diagram is you have to represent every feature. I said about IO pins, IO ports. I said about RAM and ROM. You have to represent every feature as one block. You have to represent every feature as one block. Example, to draw the block diagram, this is how the block diagram looks like. There is a CPU inside microcontroller. So you draw the CPU. Okay, now you have RAM inside 8051. You have ROM inside 8051. You have two timers and counters. So timer 0, counter 0, timer 1, counter 1. You have one UART. You have 4 IO ports. So next one is you have interrupt control unit. So oscillator is required. Interrupt control unit is available like this. So you have to connect all these on-chip peripherals to microcontroller. UART, timer 0, timer 1 like this. Like this, you have to connect to microcontroller. So it has a RAM of 128, total 256 bytes. Total 256 bytes. It has a ROM of 4 KB. It has timer 0 or counter 0. It has timer 1 or counter 1. It has UART. It has 4 IO ports. It has interrupt control unit. And it has inbuilt oscillator or clock generator. So all these are connected to the CPU only. All these are connected to CPU. So there are 4 ports are there. So you have to represent 4 ports like this: P0, P1, P2, and P3 like this. And so this bus is used to connect all these peripherals, on-chip peripherals, to the CPU. So this bus is called as local bus. It is inside the microcontroller. That's why this bus is called as local bus. Okay. So there is a local bus which is used to connect all these peripherals to CPU. Okay, so this is the logic behind drawing the block diagram. So oscillator. So this oscillator need external crystal. So you have to connect external crystal to this oscillator. XTAL is the short form used for crystal. This is the external crystal. And for 8051, you have to use 11.0592 megahertz frequency only. For 8051, you have to use this frequency only. For 8051, you have to use this frequency only. The reason is you don't use 12 megahertz for 8051. You have to use this frequency only. The reason is if you use this frequency, then only you can do serial communication properly. If you use this frequency, then only you can do serial communication properly. If your frequency is not this, then you cannot do serial communication properly. Serial communication means UART communication only. Serial communication means UART communication. So you can do UART communication properly or serial communication properly if you use this frequency. Okay, so how it is related to the UART, that we will discuss. We will discuss in the UART topic only. No, actually, the reason behind using this frequency is exact reason. Like if we use 11.0592 external crystal, then only we can set exact baud rate of UART. Then only we can set exact baud rate of UART. If we use this frequency, then only we can set exact baud rate of UART. Okay, so for time being, remember that what is baud rate, what is UART, what is the baud rate, why baud rate is required in the UART. All the details we will discuss in the UART topic. Okay, so this is how the block diagram looks like. So let me show you one more block diagram. So this is the block diagram. You can take the screenshot of this. Take a screenshot of this. Yeah, crystal oscillator will always give the constant frequency. The crystal oscillator will never change. This crystal oscillator will never change the frequency. It will always give the constant frequency. Okay, so this is the block diagram of 8051. They already said what is the logic behind this drawing this block diagram. It depends upon features of microcontroller. if more features, suppose if more number of peripherals are there, if microcontroller has inbuilt ADC, then in the block diagram also ADC will come into picture. In block diagram also ADC will come. Suppose if microcontroller has inbuilt PWM, that PWM also will come into the picture. Okay. So in 8051 we do not have the ADC or we do not have the PWM. That's why ADC or PWM is not given in the block diagram. Okay, next one we will discuss pin diagram of next one we will discuss pin diagram of 8051. This is the pin diagram of 8051. Okay, first you take a look into this pin diagram. Total 40 pins are there. Total 40 pins are there. This is the first pin. This is the last pin. So here this is the first pin. So you can observe here, okay, in this microcontroller pins, okay, now first question will come, okay, these many pins are there. How to remember all that pins? How to remember all these pins, and whether microcontroller, if I change microcontroller, whether pins will change. So that questions will be there, that we will discuss one by one. Okay, first question is microcontroller, whether this pin diagram whether this pin diagram will change if I change microcontroller. Answer is yes. Answer is yes. If you are in the same family, see, if you check the pin diagram of any 8051 version, so I already given IC numbers 8089S52. This is Atmel version of 8051. This is the Atmel version of 8051. W78E052D. This is the Nuvoton version of 8051. P89V51RD2. This is the Philips version of 8051. SST89V51RD2. This is SST version of microcontroller 8051. So all these ICs belongs to 8051. All these are 8051 versions. This is Atmel version, Nuvoton, Philips, and SST. We already discussed. Intel has stopped designing this 8051. Intel has given rights to other companies like Atmel, Nuvoton, Philips, SST. Intel has given rights to these companies to design 8051 microcontroller. So that means the pin diagram of all these version is exactly same. Pin diagram of all this version is exactly same. Programming of all this version is exactly same. Suppose these pin numbers will not change in the same family. All this belongs to the all these are 8051 family microcontrollers. So in same microcontroller, these pin numbers will not change. If you change the family, suppose if you go for AVR microcontroller or PIC microcontroller or ARM controller, then the pin numbers will change. Then the pin diagram will change. In the same family, it will not change. Yes, 8089C51. So there are number of pins or number of ICs are there. Okay, 8089C51, 8089C52, 8089S51, 8089S52. All these are Atmel versions only. All these are Atmel versions only. This is the old version. This is the new version of Atmel. So this version of Atmel is popular. So that's why whatever the popular version is there, I have given over here. So there are like number of ICs are there, like more than 30 number of ICs are available in 8051 family. More than 30 number of ICs are available in 8051 family. So whatever the popular are there, whatever easily available in the market, that I have given. That ICs are I have given. Okay. So in 8051, if you are working on any 8051 version, so then the pin diagram will not change. Okay. Next point is how to read this pin diagram. Okay, it is as an embedded engineer, if you are working as an embedded engineer, not an hardware engineer, if you are working as an embedded engineer, you only has to worry how many IO ports are available, what are the IO port numbers, and what are the IO ports, how many IO ports are available, and what are the dual functionalities, all alternative functionalities of this IO pin. Only this thing you have to remember. No need to worry about other pins also, like this is the VCC pin is there, reset pin is there, crystal pins are there, ground is there, EA is there, AL is there, PSEN bar is there. So the remaining pins are there. So no need to worry about the remaining pins, because when you are a programmer, you should only worry about IO pins. You don't worry about other pins like VCC, reset, and all that things. So that rest everything will be taken care by hardware engineer. Make sure that when you're working for any company, so you will never get two different roles in the company until unless it is not small scale industry. You will never get two different roles in the company. You will not get a role as a hardware engineer and embedded engineer. Embedded engineer means embedded programmer. So you will not get two different roles in the company. If you get placed as a hardware engineer, so you have to do hardware related things only. If you get placed as a programmer, embedded software engineer, embedded software developer, or embedded engineer. So what are the role? What are the designation? If you get placed as an embedded engineer, you have to do programming only. You should not do any hardware stuff in the company. So company will not allow you. And most of the time, I will tell you, if there is a MNC, most of the MNCs means I can say 99% MNCs, they will not design the hardware. So these MNCs, what they do is, MNCs will give this hardware designing part to small scale industries. They will give this project to small scale industries, and that's how the small scale industries are surviving in the market. So MNCs will get a project they will get the project, government project, or whatever the project, private company project, they will get the project. And suppose if any hardware is required, MNC company will not design the hardware by their own. So they will give this hardware designing part to small scale industries. Okay, so I will not regret. Okay, MNCs are not having hardware designing position. Yes, MNC do have hardware design position. Example, in Qualcomm company, Intel company, L&T company, Robert Bosch company. So these MNCs are having a hardware engineer position. You can directly go to these companies, you can work as a hardware engineer. But 99% MNCs, they will give the hardware designing part to small scale industries. And what small scale industry will do is, small scale industry will hire some diploma holders or ITI engineers, ITI students. They will hire because they are very good in the hardware designing. So they will hire these ITI students and they will do this work. So ITI students also need, like ITI students won't expect more salary, right? Diploma holders and ITI, they won't expect more salary. So small scale industry will give less salary to these guys and they will design the hardware. Suppose if these guys goes to MNC, so MNC has to pay more to these employees. So though they are ITI engineers, ITI or diploma engineers, diploma holder, so MNC has to pay more money because of the company name. Suppose if anybody's company, if any employee is working for Qualcomm, and if it is getting 10K per month, so that will actually down the reputation of this Qualcomm company. If any employee working for Qualcomm company will get very good salary. And that's why what these companies will do is, they will not hire directly hardware engineers. They will give this work to small scale industry. Small scale industry will hire these ITI holder or diploma holders because they are very good in the hardware. So they will design this hardware, they will give it to this MNC. Okay, like that. So there are some companies like Qualcomm, Intel, L&T, Bosch. They will directly hire the hardware engineers. So they will give very good salary also, but they will expect engineers only. Like they they will expect degree like BE and ME. Okay. So when you are working as an embedded engineer, you should not worry about all these pins. You should not worry about all these pins. And most of the time, so like now I got very good, now I have very good experience in the embedded programming. And suppose if I get any project, what I do is, okay, my role in the project is I have to connect one sensor to this microcontroller and I have to show this output on the computer. This is my role in the project, assume that. So what I will do in this situation is where to connect this sensor, to which pin I have to connect the sensor, and for displaying output on PC, how to write the software, how to write a program, to read output from the sensor and how to print it on the PC. That I will worry about it. So I will search a pin where I have to connect this sensor, and obviously I know if I have to connect the sensor, I have to use ADC pin only. So on microcontroller, on all these pins, I will search, okay, how many ADC pins are available, and I will decide, okay, assume that there are 4 ADC pins are available. I will decide one of the pin to connect the sensor. I will use one of the ADC pin to connect the sensor. Okay, so I will worry about this pin only. I will not worry about any other pins in the microcontroller. So this will happen, but since you are learning this microcontroller, so everything you have to understand in the detail. So what we will do is we will discuss this IO port programming. We will discuss how to connect external devices to this IO port, and what are the remaining pins. What are the remaining 8 pins are there? That also we will discuss. Brief idea I will give about all the pins. Okay. So these are the 4 ports available in 8051. We have port 0, we have port 2, we have port 1, and we have port 3. Total 4 ports are available: P0, P1, P2, and P3. Total 4 ports are available, and these are the 32 pins. These are 32 pins of 8051. These are 32 pins of 8051. So this 32 out of 40 pins, out of total 40 pins are there in 8051. So out of 40 pins, 32 pins are IO pins. 32 pins are IO pins. There are 4 ports are there. Each port has 8 IO pins. 32 pins are IO pins. And remaining 8 pins are nothing but your VCC, ground, reset, crystal pin, and some EA, EL, and PSEN bar. Okay. So these are the remaining pins. Okay. So let us start one by one. We will not go in the detail of these pins. Whenever I come to IO programming, then we will discuss these pins in the detail. This is just a brief idea. I'll give just a short introduction on these pins, and then we will move to the next topic. Okay, check it out. Let's start from port number 0. Let's start from port number 0. So port number 0 has 8 IO pins. So you can see these pins are having name also. These pins are having name also. This is called as a pin number. Or these pins are having numbers. These pins are having numbers. Observe this one. This number is 0.0. This number is 0.0. This 0.0 represents, this is the 0th pin. This is the 0th pin of port 0. 0.0 represents, this is the 0th pin of port 0. So this numbering, each port pin or each IO pin has numbers. Each IO pin has a unique number. Okay, and that numbering scheme, this numbering scheme starts from 0. You take first pin of port 1 also, first pin of port 2 also, and first pin of port 3 also. Here it is. This is 2.0, right? So you can see every port has 8 pins, and the first number of first pin starts from 0. That means index starts from 0. This is the 0th pin of port 2, 0th pin of port 1, 0th pin of port 3. So each IO pin has unique pin number. Each IO pin of this microcontroller or every microcontroller will have unique pin number. So for identification, it becomes easy. So no 2 pins will have the same number. 2 IO pins will never have the same numbers because it will conflict and we will get confused, and obviously controller programming also that gives a problem. So that's why every IO pin will have the unique number. So you can see this number starts from 0. So port 0 has 8 pins: 0.0, then 0.1, then 0.2, 0.3 up to 0.7. So 8 pins are there, 0.0 to 0.7, 8 pins are there. Okay, now you will again ask me, okay, what is this 0.0 and what is this AD0? 0.0, this is called as a default pin functionality, and AD0, this is called as alternative pin functionality. This is called as default pin functionality, and this is called as alternative functionality. This is called as default pin functionality, and this is called as alternative pin functionality. Okay, this is common in every microcontroller. This is common in every microcontroller. So in microcontrollers, one pin may have two different functions. One pin may have two different functionalities. One pin may have two different functionalities in microcontroller. This is common. Okay, so if microcontroller, if one pin of microcontroller has two functionalities, then this IO pins are called as dual pin functionalities. If one IO pin of microcontroller has two different functionalities, if one IO pin of microcontroller has two different functionalities, then it is called as dual pin functionalities. Then it is called as dual pin functionalities. So one pin has two different functionalities. It is called as dual pin functionalities. Okay, at a time we can use only one functionality. You can use default functionality or you can use alternative functionality. At the same time, two different functionalities cannot be used. You cannot use default and alternative pin functionality at the same time. We cannot use default pin functionality and alternative pin functionality at the same time. Okay, in this case, default pin functionality of any pin is IO pin. By default, all pins acts as a IO pins. All pin acts as a IO pins. By default, all pin acts as a IO pins. So the default pin functionality of every IO pin, every pin is IO pin only. Default functionality of every port pin is IO pin. Alternative functionality that depends upon the port. Alternative functionality that depends upon the port. Okay, so now understand. Now one point you can write: default functionality of any port pin. Default functionality of any port pin is IO pin. Default functionality of any port pin is IO pin. Default functionality of any port pin is IO pin. Okay, now alternative functionality that depends upon the port. Alternative functionality depends upon the port. Okay, so before going to this explanation of alternative pin functionality, I would like to clear one point. I think I already said many companies, they will not prefer external memory interfacings. Many companies, they will not prefer external memory interfacing, like external RAM or external flash memory. Take any controller. Companies will not prefer external memory interfacing. The reason is if external memory is interfaced with the microcontroller, that will increase the PCB size. So without external memory, PCB size will be smaller. So on the board, you will have the microcontroller. But if external memory is interfaced, that increases external memory the reason behind not interfacing the external memory, that increases the PCB size, and that increases the PCB size, and that increases the PCB cost also. That increases the PCB size. If the PCB size increase, the product size will increase. If the PCB size increased, product cost will also increase. Hope you're getting that point. So that's the reason companies won't prefer external memory interface. If external memory is interfaced, that increases the cost of the product. What are the final product is designed? Example, what are the product? You take any pulse oximeter product, AC washing machine, electric oven, that thermometer you take any medical, this one, you take any Bluetooth mouse, Bluetooth headset. So if external memory is interfaced to microcontroller, that increases the PCB size, that will increase the product cost and product size also. And that's the reason most of the time companies will not prefer external memory interface. Okay, if they want, see, the reason behind going for external memory interface is, if internal memory is insufficient, then we go for external memory interface. Example, in your mobile phone, suppose if the internal memory of mobile phone is insufficient, you connect memory card. You will go for external memory support, right? The inbuilt memory of mobile phone is insufficient. So that's why we connect memory card and we'll go for external memory interface and external memory, like will depend upon the external memory for more storage. Here also, if the internal memory of microcontroller is insufficient, then only company will use the external memory. But nowadays, in industries, in this microcontroller design, in the microcontroller, so one microcontroller will have different series. One microcontroller will have different series. Series 1, Series A, Series B, Series C, like that. Like this, it will be there. So Series A will have less number of RAM, less number of flash memory. B will have more RAM, more flash memory. C will have more RAM and flash memory than A and B. D will have more RAM and flash memory than ABC. Like that version, different versions will be there. So what company will do is, based upon project requirement, they will select one of the series of microcontroller. They will check, okay, whoever taking care of the project, that person will know what should be the RAM requirement and what should be the flash memory requirement. And based upon the requirement, they will select microcontroller. Okay, it is not like, okay, first you select microcontroller, start programming. Later on, now we are actually lagging with memory. Later on, we need more memory in the project. So in that case, the company will not connect external memory. They will go for the next version again. Okay, so that means without changing the PCB size, they can go for next version of microcontroller and they will do it. Okay, so here also what we'll do is, we will not discuss how to interface external memory. Here we will not discuss this topic. How to interface external RAM or how to interface external flash memory to 8051, or in case of ARM also we will not discuss. Okay, because the companies won't prefer interfacing of external memory. If they need more memory in the microcontroller, they will go for next version of microcontroller. That's it. If they need more memory, they will go for the next version. They will not connect external RAM and flash memory because of the product size issue and because of cost issue. Obviously, nowadays, like, we are getting Bluetooth headset starting from 500 rupees. Suppose if the Bluetooth headset cost starting from 3,000 or 4,000, most of the people cannot afford that product, right? So if this type of mistakes are done by the designer, then obviously product cost will increase. Okay, so we will not discuss the interfacing of external memory, but I will give one idea about this external memory interface. I'll give one idea about external memory interface. In case of 8051, okay, first point to remember, suppose if I want to interface external memory, then with the help of address bus and data bus, I can interface external memory. With the help of address bus and data bus, I can interface external memory. To interface external memory, we have to use address bus and data bus. That's it. You remember this point? This is the basic point. This is the external memory, and this is any microcontroller. This doesn't belong to 8051. Any microcontroller. Take any controller. If you want to interface external memory like RAM or flash memory, then you have to use address bus and data bus. That's it. And in the case of 8051, the data bus is available on port 0 and address bus is available on port 0 and port number 2. Port 0 and port number 2 has address bus. Total 16 address buses are there. That's why it is not possible to have 16 address bus on one port only. Okay, to interface external memory, we have to use port 0 and port 2. We have to use port 0 and port 2 of 8051. Okay, so you can check the alternative pin functionality. First, you make a note of this. I'll remove this one. To interface external memory, we have to make use of address bus and data bus. Whatever it is, you have to remember that point. Okay, only this basic point you remember it. Okay, now check here. So port 0, default functionality of the port 0 is IO port. I can use port 0 as a IO port. Okay, so default functionality is all pins of port 0 act as a IO pins by default. And this is called as alternative pin functionality. And the alternative pin functionality of port 0 is alternative pin functionality of port 0 is it can be used as multiplexed data and address bus. Multiplex means together, combined. Address and this AD0 stands for A0 D0, like that. AD1 stands for A1 D1. So there is something called as a multiplexing. So as I told you, like, we will not go in the details of this one, because again it will take one more session how to interface external memory. So we have some other important topics to discuss in microcontroller, but remember that one. Right now I'm in the pin diagram explanation. So you should know what is the alternative functionality given for this port. So upon reset, all pin acts as a IO pins. All port pin act as a IO pins. Upon reset, all port pin act as a IO pins. So port 0 alternative functionality is it is having multiplexed address and data bus. And port 2 alternative functionality is it can be used as higher order address bus. It can be used as higher order address bus. So port 0 will act as a lower order address and data bus, and port 2 alternative functionality is higher order address bus. So in case if you want to connect external memory like external RAM or external flash memory, then you have to make use of port 0 and port 2. But one of the disadvantage of interfacing the external memory is, suppose if you interface external memory to 8051, then port 0 and port 2 becomes busy. The port 0 and port 2 becomes busy in address line, address data line, address and data lines operation. So at the same time, port 0 and port 2 cannot be used as IO pins. If you interface external memory, then port 0 and port 2 becomes busy for address and data operation, and port 0 and port 2 cannot be used as IO. Port 0 and port 2 can be used as IO pins at the same time. So out of 32, 16 pins are busy for external memory operation and 16 IO pins are available. So with the help of 16 IO pins, you can connect very less number of external devices. Suppose if your project requirement, suppose if the project requirement grow and suppose if you need more number of IO pins, so then that becomes difficult to manage the things. So that's the reason interfacing of external memory we will avoid it. So we'll not go in the details of this address and data bus. No, at a time it is not possible. That's why I'm saying. Question is, can we use port 0 as IO pin and alternative at the same time? Answer is no. It is not possible. At a time, we can use only one functionality. Either you go for external memory interface or you do IO operation. At the same time, two things cannot be done. Okay, so this is about port 0 and port 2. We'll not go in the details of this one. Just remember port 0 default functionality is IO pins. Alternative functionality is it can be used as multiplex address and data bus. Port 2 default functionality is IO pins. Alternative functionality is higher order address bus. What about port 1? What about port 1? What do you think about the port 1? They have not given any other option here. They have not given any other option here. Yeah, K2 and B4, you're right. See, they have not given any alternative functionality here. That means port 0 can be used as IO port only. Port 0 can be used as IO port only. Port 0 can be used as IO port only. See, port 1 can be used as IO port only. Only port 1. See, out of four ports, only port 1 don't have the alternative functionality. Only port 1 doesn't have alternative functionality. Except port 1, remaining ports are having alternative pin functionality. We discussed port 0, we discussed port 2. Port 3 also has alternative functionality, as you can see over here. But port 1 doesn't have alternative functionality. So port 1 has only, port 1 can be used as IO pins only. Or port 1 can be used as IO port only. Okay, now come to the port number 3. Default pin functionality of the port number 3 is IO pin. Yeah, N1 we can say it is a single pin or single pin functionality. It is having only one functionality, that is IO pin. Okay. So come to the port number 3. Default functionality of the port 3 is it can be used as IO port or IO pins. All pins of port 3 can be used as IO pins. All pins of port 3 can be used as IO pins. And this port 3 has alternative functionality also. Port 3 has alternative functionality also. Port 3 has alternative functionality also. So check the alternative functionality of the port number 3. Check the alternative functionality of the port number 3. See, 3.0 and 3.1 by default, these two pins can be used as IO pins. 3.0 and 3.1 by default they can use as IO pins, and 3.0 and 3.1 has alternative functionalities. 3.0 can be used as receiver pin and 3.1 can be used as transmitter pin. So these are nothing but an UART pins. So this is alternative pin functionality. Alternative pin functionality of 3.0 and 3.1. This is the alternative pin functionality of 3.0 and 3.1, RXT and TXT. So they are used for UART. Suppose if you are using UART, if you are doing serial communication, then this 3.0 and 3.1 can be used as RXT and TXT pin. Okay, come to this 3.2 and 3.3. Come to this 3.2 and 3.3. 3.2 and 3.3 default functionality it can be used as IO pins. 3.2 and 3.3 default functionality is it can be used as IO pins, but alternative functionality is INT0 bar and INT1 bar. Yes, these two pins for UART only. These two pins are used for UART only. So I will write these are the alternative functionalities and designed for UART only. Okay, so INT0 bar and INT1 bar, these are called as external interrupt pins. These are external interrupt pins. INT0 bar, INT1 bar, these are the external interrupt pins. Default functionality of 3.2 and 3.3 is IO pin. Alternative is INT0 bar and INT1 bar. Okay, when I come to the programming, when I come to the UART or when I come to the external interrupt handling, so that time I will explain how to use this pin as a RXD pin, how to use this pin as a TXD pin and all that things. Okay. Now come to this one, this T0 and T1. This T0 and T1, these pins belongs to timers. This two pin belongs to timers. This two pin belongs to timers, T0, T1. And write bar and read bar, these two pins are used for external RAM interfacing. These two pins are used for external RAM interfacing. No, at a time you can connect only one device to one IO pin. At a time you cannot connect two devices to one IO pin. For ADC, we do not have inbuilt ADC in the 8051. We do not have inbuilt ADC in the 8051, and that's why we do not have ADC pins. We do not have inbuilt ADC in the 8051. That's why we do not have ADC pins in the 8051. Okay, suppose if you want to interface the sensor and if you want to use the ADC in the 8051, then you have to connect external ADC to 8051. We have to connect external ADC to 8051. Yeah, asset counter pins. Asset is asking what are the counter pins. Actually, these pins are counter pins only, T0 and T1. These are counter pins. So at this stage, students will get confused. Okay, why these pins T0, T1? These are the timer. This looks like a timer. So, but these two pins are nothing but an counter pins only, 3.4 and 3.5. This is called as counter 0 pin, and this is called as counter 1 pin. This is called as counter 0 pin, and this is called as counter 1 pin. These are the same pin, timer and counter. These two pins are used for timer and counter operation. Okay, so this is about port 3. So port 3 has some mixed functionalities. So when I come to your topic, we will discuss more on 3.0 and 3.1 pin. In the interrupt topic, we will discuss more on this 3.2, 3.3. These pins are called as INT0 bar. So there is a line on the INT0. This line represents bar. And this bar represents it is active low. This bar represents active low. And active low means when we give 0 on this pin, when we give 0 on this pin, 3.2 pin, then only something will happen inside microcontroller. When we give 0 on this pin, then only something will happen. That's why it is called as active low. If it is active high means when we give 1, then only something will happen inside microcontroller. Okay. So we will discuss in detail like what is this INT0 bar, INT1 bar, that we will discuss in detail in the interrupt topic. In timers and counters topic, we will discuss T0 and T1 pins. These are used for external RAM interfacing, so we will not discuss these two pins, write bar and read bar. Okay, but we will use remaining all IO pins in the programming. We'll use remaining all IO pins in the programming. Okay. Now we can see these remaining pins. We have remaining 8 pins. These remaining 8 pins are called as special pins. Out of 32, the remaining 8 pins are called as special pins. The remaining 8 pins are called as special pins. So we have VCC, we have ground, we have reset pin, we have crystal 1 pin, we have crystal 2 pin, we have EA bar, we have PSEN bar, and we have address latch enable ALE. So remaining pins are special pins. So this is also EA bar, you have to use it. It is active low pin. PSEN also active low pin. This is EA bar, PSEN bar, and ALE. Yeah, you can connect digital sensor directly to microcontroller. Yes, it is possible. And you can connect digital sensor to any IO pin of microcontroller. Okay, question is, can we connect digital sensor directly to 8051 microcontroller? Answer is yes. We can connect digital sensor directly to any IO pin of microcontroller. There are 32 IO pins are there. Use any IO pin to interface digital sensor. Okay. So come to the 8051. This 8051 works on 5 volt. Ground is the reference point for all electronic circuit. The reset pin is used to reset the controller. Crystal pins are used for providing the crystal, that we will discuss later. So EA bar, PSEN bar, and ALE, these 3 pins are used for external memory interface. These 3 pins are used for external memory interface. These 3 pins are EA bar, PSEN bar, and ALE. These 3 pins are used for external memory interface. Okay, so we will not discuss these 3 pins in the detail. Will not go in the detail of these pins. We will discuss reset pin, crystal pins in detail. VCC is nothing but it's as you know, every electronic device need a power. It need a voltage. So that voltage is given from this VCC. Ground is the reference point for all electronic circuit. Without ground, this electronic circuit will not work. Without ground, electronic circuit is incomplete. So that is the reference point for all electronic circuit. This is the VCC we have to give it. That is the pin number 40. Pin number 20 is the ground. So we will discuss more on reset and crystal pins. We'll not go in the details of this EA, PSEN, and ALE bar, ALE pin. These are used for external memory interface. Okay. So suppose if you're interested to know more about external memory interfacing, or if you want any reference book. So for reference, you can refer this Mazidi book. Mazidi book. Mazidi is the name of author. So you can read 8051. You can read 8051 concepts from Mazidi book. Another author is Ayala. Another author is Ayala. There are 2 authors are there, and these 2 books are very good books available on the internet. PDFs are available. Try to download the PDF. But the PDF of Mazidi book and Ayala book is not yet released. If you are in the Bangalore, some actually they have given Mazidi and Ayala book PDF, but they have not given the complete information inside PDF, which is available online. And if you are interested, you can come down to the lab, and in the lab we have this Mazidi book and Ayala book. Otherwise, if you can refer our material also. Our vector material is enough for technical concepts. Okay, if you want more theory concept, you can read Mazidi book or Ayala book, any book. These 2 books are available in the library. You can come down to the institute and you can take these books and you can read it. Okay. Otherwise, try to download online PDF, but they have not given much information in that PDF. Okay. So in the next session, we will discuss more on reset, crystal, and crystal 2. Okay. Yes, Ethernet also we can connect to 8051, but we have to use some converter, USB to Ethernet converter. You have to use it. USB to Ethernet converter you have to use, and then you can connect it. That is possible. Okay, so we will discuss more on this reset and crystal fill in the next session. And in the next session also, like we'll start internal RAM architecture. Okay, so today